Hi, and welcome to the Get Into Cloud podcast. My name is Coin. Today, we're going to talk about DevOps. So it's really exciting to get started talking about some of these higher level and more technical subjects. I want to give you a little bit of an idea of concepts of DevOps and then talk about how you can learn more about DevOps and look to DevOps as a potential career. Now, as you guess from the name, the general idea of DevOps is to bring development and operations together to create this unified deployment pattern. And really the goal is achieved through the use of automation and tooling called CICD pipelines. Now, you may have heard of CICD before. CI stands for continuous integration, and CD stands for continuous deployment. And those two things work together. And so you'll hear folks talk about CI/CD pipelines. Really, with the CI piece, the continuous integration, the idea is that new code is constantly being integrated into the code base. It's getting merged together with the existing code and added into the system and reconciled with the existing code. And CD means, which is continuous deployment, means that the code is constantly being deployed into running systems and ultimately into the production environment. The term used for the folks that run these systems is create and run these systems is DevOps engineers or platform engineers. Sometimes they are called DevX engineers. DevX stands for developer experience, but these are all kind of different ways to talk about the same thing. Who is creating the CI/CD pipelines, who is running them, doing the maintenance and care and feeding for these items. One thing that's a little bit of a misnomer is that DevOps is not infrastructure as code. It is not Terraform or CloudFormation specifically, but they often go together, managed by the same platform engineering teams and those things. But they are different concepts in terms of what your end goal and strategically what you're trying to accomplish with those things. I think you'll see as we go through this DevOps episode and you compare it to the infrastructure as code episode, you'll see kind of the heavy difference between what those automations are for and what they're meaning to accomplish. But it is common for folks that are in DevOps engineering roles to manage the infrastructure as code and do code in Terraform as well as a part of the deployment processes. Okay, so let's talk about kind of the old way of doing things or the worst case scenario of software deployment. So imagine you're at a company that develops some kind of software for end customers. Developers are writing features or doing code, creating code for your software. They're not exposing anyone else in the team to the changes they're making in the code. And potentially this is an old school company that's driven by release dates. Maybe they've publicly said that version 2 is available coming in on March 31st, the end of Q1. And so you have folks that are driving towards a date as opposed to releasing software on a regular basis. And so their developers are working on their code. It's not being shared with anyone else. And then as you get close to the date where it's released, they are packaging up all their code changes, everyone together, and tossing grenades over the fence to the operations team. So the software teams are just shipping it over. They're delivering all that code to the operations teams. The operations teams attempts to deploy it into the new environment. The deployment fails. Code from one developer conflicts with code from another developer. Maybe one developer is making updates to an API that another developer's feature relies on, and they're not communicating. They're not aware of those changes happening. And then once that gets into production, everything fails. Everything has to be rolled back. And of course, the ops teams just throw it right back over the fence to the development teams, which causes a lot of rework, wastes a lot of time, forces them to miss their deadline for their version 2 release and things like that. So that is kind of the worst case scenario, the old way of development and operations just working together in a poor fashion. So then what does the best case look like, the pie in the sky? Well, imagine another scenario where the developers are coding new features and they're pushing those features into a continuous integration tool, and they're using Git or GitHub or these kinds of tools to push their code on a regular basis. And so the code is being reviewed, it's being seen by other folks, and as developers who are pushing code that maybe relies on code that's changing, they're going to see those changes happening in the environment as they are pushing their code as well. So they're able to make changes to see what's coming. They're able to adjust their code as it goes so that when it's ready to be deployed into production, it doesn't have some issues with other code that's changing at the same time. It's being reviewed by senior people. There are gates in place to make sure code builds are working. Code is reviewed before it's pushed and built. It's bundled up and there are tests run against it. It's scanned and then it's being released in the dev and test and staging and finally production. And all the while, feedback is being pushed back to the developer as fast as possible so they can adjust and update their code. And because they are pushing code in smaller chunks, that means if there are problems with the code, they can be fixed in a much shorter time frame. And so they're doing much smaller code releases, and they're doing them more often, and they're getting feedback sooner. And so you're able to produce code that's much more robust in a much faster turnaround time, and then get feedback faster from your internal teams, from your tooling, and then also from your clients as well. So what are the major components here that kind of makes that pie in the sky a reality? Well, the first thing that is the most common is Git. Git is the continuous integration technology in the CICD process. This is the version control tool that allows developers to work on code simultaneously and merge the code changes together in a sensible way. And there are platforms like GitHub, GitLab, Bitbucket, and others that facilitate the use of Git to merge those things together, to have code reviews and approval gating for code to continue down a path to production. And they also additionally provide a lot of automation and things in place to help manage the continuous integration pieces as well. The next kind of big piece, major component, are builds and tests. So tools like GitHub and GitLab can put builds in place so they can attempt to build the code and make sure that it's going to build effectively. They can make sure that tests are run against the code. Most languages, I would say all languages, have testing frameworks that you can use to lint the code to make sure the code is written in the correct syntax for your company. You can build the code and make sure it's going to pass the initial build. You can run unit testing and make sure that every time someone creates an account that the desired result happens, or runs this code, that the desired results happen and undesired results can't happen as well. And so this is all automated as part of your CI/CD pipelines. And then the third major piece that we talked about is the continuous deployment. So typically your continuous deployment platform is going to be an extension of your continuous integration platform. As I mentioned, GitHub and GitLab are popular today. It wasn't always the case that GitHub and GitLab or like GitHub Actions or GitLab pipelines or Bitbucket pipelines, those didn't exist before. You would use separate tools to be able to deploy those items. So it was popular in the past to use Jenkins or GoCD or some of these other continuous deployment platforms to basically you would hand off your code from Git and GitHub, which only did continuous integration. You'd hand it off to some continuous deployment platform, and then that would deploy it. But I think recently, both the cloud providers and the SaaS providers have pushed further into the continuous deployment area as well. It makes sense that if you are GitHub as a company, that you're owning both the code and the deployment as part of a full DevOps pipeline. And so there are a lot of tools. On AWS, it's Code Pipeline. In Azure, it's called Azure DevOps. And those are very popular, certainly if you're all in on a particular cloud platform in terms of the CI/CD pipeline. I will say in AWS, Code Commit is their CI tool. It's not a very mature tool, and so folks don't tend to use that. They would tend to use something like GitHub or some other tool. and for that. And folks tend to save their code base in one centralized place across things that apply to both cloud and not cloud. So I would say in my experience, most folks don't keep their code base in a continuous integration tool inside of a cloud native solution, but they will commonly use the code deployment, continuous deployment tools inside of cloud native solutions like Code Pipeline or Azure DevOps. Now, I did mention Jenkins, and in my opinion, Jenkins will continue to see decline as companies want to consolidate. One big thing that happens at all corporations is they look around and see that they have 5 different tools to accomplish one goal, and then they will seek to consolidate those tools around one tool if that one tool can do that job good enough. So that's pretty common for what I've seen, where folks maybe started with GitHub for their continuous integration and use Jenkins for their continuous deployment, start to move those deployment pipelines into GitHub Actions so they can have a single SaaS provider, supported SaaS provider to be able to do all of those things. It just makes sense if you're already using GitHub to not have to have skill sets for both GitHub and Jenkins when you could have skill sets for just GitHub and GitHub Actions. That said, Jenkins is cheap. Many of the continuous deployment pipeline toolings are open source and inexpensive, and so they will remain to be popular for those that can't afford to use any alternatives. But I will see, in my opinion, Jenkins will continue to see decline as other tools are coming into favor. Now, what should you know in terms of these tools and DevOps in general? I would say that it's going to be important to take time to learn both the CI and CD side of this. You should be very familiar with Git generally on the command line and how to create branches, delete branches, merge branches, how to cherry pick commits, how to do a commit, how to do commits and update messages on a commit, squash commits together, and just kind of the basic care and feeding that you need to do to take care of your code from a Git perspective. And then, of course, you'll want to be familiar with GitHub as the gold standard for SaaS continuous integration tooling. You should have your own GitHub. You should be posting and saving your projects there. And you can use your GitHub to be able to interact with open source projects. So if you heard my episode on Python and learning programming, one thing that you can do to practice programming, and also by practicing programming, you can practice also your Git continuous integrations by submitting code to open source projects and learning how to do pull requests and how to engage with the reviewers around comments, how to read the contributions, how to squash your commits together, and then push those to the project that you want to be a part of. So learning Git and learning how to interact around pull requests and commits and things like that, very important, because it's highly likely, certainly as a DevOps engineer, but even as a cloud engineer, you'll be interacting with Git and GitHub in some form or fashion. And I think it's important to keep your own copy, have a GitHub account for yourself, keep copies of your projects there and publicly available so that folks can review the kinds of things you're working on. From a continuous deployment perspective, it's fine to learn Jenkins and get to know Jenkins. You can get to know Code Pipeline in AWS if you're focused on AWS. I don't know that GitHub Actions, which is important to learn, but I don't believe there's a free tier for that. So I would be careful about potentially playing around in that. It might be better to play around in Code Pipeline and do some testing and experimentation with the continuous deployment from a Code Pipeline perspective, and that might be the right approach to get some experience and do some projects for that. So one other thing I want to draw your attention to is called DORA. That is the DevOps research and assessment done by Google to understand how companies are using DevOps and to build a strategy for grading your DevOps maturity and your DevOps progress. And so you can go to dora.dev to learn more about this research that they've done, but they break down DevOps into 4 basic metrics. And the first metric is deployment velocity. So how long does it take a code that gets pushed to make it into production? So what does that time frame look like? The second is change failure rate. What is the percent of deployments that need to be hot fixed after they are moved to production? The third is your deployment frequency. How often are you deploying to prod? Once a day, once a week, once a month, twice a year. So measured in how many days it is between, or how many weeks it is between your deployments to production. And the fourth is the mean time to recovery. So when you do have a deployment that fails into production, how long does it take you to recover back to a known good pattern where production has recovered? And those 4 metrics are used to determine where you are from a maturity perspective and the things that you need to improve. The goal, of course, is to deploy faster to production, increase your deployment velocity, to deploy more reliably to production, so lower the percent of your change failure rate, to deploy more often, to make smaller, more often deployments to production, so that's to increase your deployment frequency, and to roll back your failed deployments faster, which is to reduce the mean time to recovery. And the goal is to measure these things and to make improvements where you can on each of those things. And there are a lot of levers, of course, to making those improvements, but measuring those things and being cognizant of them is the first step to improving your DevOps performance. And the truth is, a lot of companies are just getting started on their DevOps journey, so they have a long way to go. But measuring these things and these metrics are important to understanding how to improve your DevOps performance. And the last thing I'll talk about is you'll also hear a term called shift left. And that concept is a part of kind of a DevOps concept. And it's really about, how do I give feedback to the developers? So you think about a diagram from left to right, you have the developer on the left and the operations person in the middle and production on the right. And that pathway, the goal is to shift responsibility and feedback left to the developer so that the developer can make important decisions about developing the code in a way that's going to answer for what is going to be delivered into production. And so if the developer codes something that is insecure, they code a listener on port 80 that should be listening on port 443 for HTTPS, then in the CICD process should at some point scan that information and provide feedback back to the developer to say, hey, you've coded a listener in this product that is in your feature that is insecure, and you need to update that code, right? And so it's not that the code makes it all the way into production and then a pen test is done that discovers that you're listening on an insecure port. It's that those things are fixed by the developer because that feedback is given to them as part of the process. And so what is delivered to production is more robust and has already been vetted more frequently and more thoroughly than otherwise would be. Thanks so much for listening to this episode of the Get Into Cloud podcast. I created this podcast to help people just like you who want to start and accelerate their cloud careers. Please take the time to like, subscribe, click, follow, do all the things on whatever platform that you use to listen to this podcast. We want to spread the word so that everyone can know that there's a pathway for them to get into cloud. Thanks so much for listening. Thanks for your help. Have a good day.